The topic is double integration. Let us see double integration in Cartesian coordinates and in polar coordinates. Before passing on to the integration, let us see what is meant by Cartesian coordinate system and polar coordinate system. In our earlier classes, we have studied how to plot a number 5, 3. How you can plot a number 5, 3. That is, we are going to take 5 units in the x-axis and 3 units in the y-axis, and this point representation in x and y coordinate system is 5, 6. This representation of a point in x and y, this coordinate system is called rectangular coordinate system. This is called Cartesian coordinate system. Similarly, we can also express any point P in terms of r, theta. This representation is called polar coordinate system. Let us see what is meant by r and what is meant by theta. R is nothing but the distance from the origin to the respective point. Theta is nothing but the angle made by the line with the x-axis. This is the point P r, theta can be represented as P r, theta. In this, r denotes the distance from the origin to the respective point, and theta is nothing but the angle made by this line OP with the x-axis. This representation is called polar coordinate representation. This is Cartesian coordinate representation. In terms of x and y, it is called Cartesian coordinates. Now we are going to see double integration in Cartesian coordinates. The integral y1 to y2, integral x1 to x2, f of x, y dx dy is a double integral, in which we are going to integrate the function f of x, y first with respect to x, then we are going to substitute the x limits. Then the resulting value is integrated with respect to y between the limits y1 and y2. This is the concept of double integration. I will repeat once again. The function f of x, y is first integrated with respect to x between the limits x1, x2, and the resulting expression is evaluated with respect to y between the limits y1 and y2. This is called double integration. Now let us see some types of double integration. There are 3 main types in double integration. The first one, if both the x1 and y limits are constants, if both the x limits and y limits are constants, then the integration or the order of integration is immaterial. That is, we can first integrate with respect to x, or we can first integrate with respect to y, or vice versa. That is, if both the limits are constants, means then the order of integration is immaterial. That is the first type. The second type is, if the x limits are expressed in terms of y and y limits are given as constants, then first integrate with respect to x and then integrate with respect to y. This is the order of integration. First with respect to x, second with respect to y. That is, if the limits, x limits are in terms of y and y limits are constants, means first integrate with respect to x, then integrate with respect to y. Now let us pass on to the next type, the third type. Here the y limits are expressed in terms of x and x limits are constants. So here the order of integration is, first integrate with respect to y, then integrate with respect to x. So this is the method of evaluating the double integration. Now let us solve some of the problems in double integration. The first problem is integral 0 to 3, integral 0 to 1. The function is x square plus 3y square dy dx. Here, if you take this as y limits are given in terms of constants, x limits are also in terms of constants. Therefore, the order of integration is immaterial. You can integrate in any order. First I am going to integrate with respect to y. integral 0 to 3, I am going to integrate this expression with respect to y. Therefore, this will become x square y plus 3 into y cube divided by 3 between the limits 0 to 1 into dx. Integral 0 to 3, substitute the upper and lower limits for y value only. Therefore, this will become x square into 1 plus y cube, y value equal to 1. Therefore, 1 cube is 1. This is upper limit minus of the lower limit. I am going to substitute for y. 0 and anything 0. Here 0 cube, so that is also equal to 0 into dx. Integral 0 to 3, this is simply x square plus 1 into dx. So first we have integrated with respect to y and substituted the y limits. Now we are going to integrate the resulting expression with respect to x. When you integrate x square, this will become x cube by 3 plus dx on integration gives you x between the limits 0 to 3. Substitute the limits. When you substitute the upper limit, this will become 3 cube divided by 3 plus 3 minus the lower limit value equal to 0. When you cancel this will become 3 square, that is 9. 9 plus 3, which is equal to 12. This is the required answer. Now, the first limits are, if the x and y limits are constants, the order of integration is immaterial. In the second problem, what is this? Y and 3y. This cannot be y limits because y limits cannot be expressed in terms of y. Therefore, this must be x limits. Therefore, it is given x as a function of y and the remaining is 1 to 2. This is nothing but y limits. Y limits are given in terms of constants. So what is the order of integration here? First you are going to integrate with respect to x. Second you are going to integrate with respect to y. So this is the method. Now I am going to solve this problem. Integral 1 to 2. I am going to integrate this x plus y with respect to x. So x on integration will gives you x square by 2 plus the second term y. I am going to integrate this with respect to x. Therefore, this will become xy dy. Since I have integrated with respect to x, now I am going to substitute the limits. What are the limits? The limits are y to 3y. Substitute the limits. Substitute the upper limit. So x square. So when you substitute x equal to 3y, this will become 9y square by 2 plus, here instead of x I am going to substitute 3y into y, that is 3y square. I have substituted the upper limit minus the lower limit value y square by 2 plus, instead of x I am going to substitute y. This will become y square. Let us simplify this. Integral 1 to 2. This is 9y square by 2 plus 3y square minus y square by 2. When you release the bracket, this will become minus y square into dy. Integral 1 to 2. 9y square by 2 minus y square by 2 gives you 8y square by 2, that is nothing but 4y square plus 3y square minus y square, which is equal to 2y square dy. Integral 1 to 2, this will become 6y square dy. Now I am going to integrate this with respect to y. Y square on integration gives you y cube divided by 3 between the limits 1 to 2. Simplify this 3 and 6. Therefore the resulting expression is 2y cube. I am going to substitute only for the limits only for y cube, which is equal to 2 into, when you substitute the upper limit, this will become 2 cube. When you substitute the lower limit, this will become 1 cube, which is equal to 2 into 2 cube is nothing but 8. 8 minus 1, 7. 7 2s are 14, which is a required answer. Now the third problem is integral 0 to 1, integral x square to x dy dx. Here this x square to x is nothing but y limits, y equal to x square, y equal to x. Therefore, y is expressed as a function of x. And the 0 and 1 are nothing but x limits, x equal to 0, x equal to 1. That is, x is expressed as constants. So what is the order of integration? First I am going to integrate with respect to y. Second I am going to integrate with respect to x. Let us start the integration procedure. I am going to integrate first with respect to y. dy on integration gives you y between the limits x square to x. Substitute the limits. When you substitute the upper limit, this will become x minus x square dx. When you substitute the upper limit, this will become x minus lower limit. Instead of y, we are going to substitute x square. So x minus x square dx. Now integrate this expression with respect to x between the limits 0 to 1. X on integration gives you x square by 2 minus x square on integration gives you x cube by 3 between the limits 0 to 1. Substitute the limits. When you substitute the upper limit, this will become 1 by 2 minus 1 by 3. For the lower limit 0, the term vanishes. Therefore, it contains only 1 by 2 and 1 minus 1 by 3. When you take LCM 6, this will become 3 minus of 2, which is equal to 1 by 6. So this is the answer for the third problem. That is, the third problem, the concept is, since y limits are given in terms of x, you have to integrate first with respect to y. X limits are given in terms of constants. You have to integrate secondly with respect to x. This is the main idea behind this evaluation of double integration. So double integration contains three methods. If the first method is, if the limits are constants, if both x and y limits are constants, then the order of integration is immaterial. You can integrate first with respect to x or with respect to y or vice versa. The second method is, if x values are given in terms of y and y values are given in terms of constants, the order of integration is, first you have to integrate with respect to x, then you have to integrate with respect to y. The third type is, if y values are expressed in terms of x and x is given in terms of constants, the order of integration is, first you have to integrate with respect to y, then you have to integrate with respect to x. Let's solve the fourth problem. The problem is integral 0 to a, integral 0 to a square minus x square. The function is x plus y dx dy. We are going to evaluate this integral. First let us see the order of integration. This is nothing but y limits. Y equal to 0, y equal to square root of a square minus x square. Therefore this is x limits, x equal to 0 and x equal to a. So x limits are given as constants and y as a function of x. So first we are going to integrate with respect to y, then with respect to x. This is the order of integration in the evaluation of this double integral. So here it is given dx dy. Don't bother about the order in the given problem, that is dx dy. See the limits and find the order. Therefore let us change the problem as integral 0 to a, integral 0 to square root of a square minus x square x plus y. Since we are going to first integrate with respect to y, write this as dy then dx. So you can change this. Don't see this order, this dx and dy. See the limits and identify the order. After verifying the limits, we have concluded that first we are going to integrate with respect to y and then with respect to x. So change this dx dy as dy dx. Let us start the integration. I am going to integrate with respect to y. Therefore this will become xy plus y square by 2 between the limits 0 to square root of a square minus x square into dx. Integral 0 to a, I am going to substitute the limits for y values. X into square root of a square minus x square plus y square. Y square means square root of a square minus x square whole square. That will become simply a square minus x square divided by 2 dx. Now I am going to integrate this expression with respect to x between the limits 0 to a. Let us take this as equation number 1 and consider the first integral. This consider integral 0 to a integral x into square root of a square minus x square dx. I am going to evaluate this integral. How we can evaluate this integral? Let us integrate this by substitution. Put t equal to square root of a square minus x square, or you can also take the substitution, put t equal to a square minus x square. So find dt by dx. Differentiating this t with respect to x, this gives you minus 2x. I have to find only x dx value. Therefore, x into this dx gives you dt by 2, that is minus dt by 2. Now let us see the limits. What are the x limits? X limits are 0 to a. I am going to change this in terms of t limits. So when you put x equal to 0, what is t value? T equal to a square. When you put x equal to a, what is t value? 0. Therefore, the given integral becomes integral 0 to a becomes integral a square to 0. Then this x dx can be written as minus dt by 2. Minus dt by 2. I have written x dx. Now square root of a square minus x square. That is, we are going to substitute a square minus x square as t. Therefore, this will become root t. Now we can change the limits, because minus integral a square to 0 can be written as integral 0 to a square by using the definite integral property. That is, integral a to b f of x dx is equal to minus b to a f of x dx. By using this definite integral property, I can change the limits a square to 0 as 0 to a square. Then this root t is nothing but t power half dt. Now I am going to integrate the t power half. T power half on integration gives you t power 3 by 2, that is t power half plus 1. By using the formula, what is the formula I have applied? Integral x power n dx equal to x power n plus 1 by n plus 1. Here n value equal to half, so that our integration gives you t power half plus 1, that is 3 by 2 divided by 3 by 2 between the limits 0 to a square. So 1 by 2 into this 1 by 3 by 2 can be written as 2 by 3. T by 3 by t power 3 by 2, I am going to substitute the limits, that is a square power 3 by 2 minus, instead of t I am going to substitute 0, that will become 0. Therefore, this will become 1 by 3. A square power 3 by 2 will become a cube. So that gives the answer as a cube divided by 3. This is the integral answer for the first part only. That is, I have considered from equation number 1 the first part, integral 0 to a x into a square minus x square dx. Similarly, we are going to integrate the second part. Now we are going to integrate the second part, that is 1 by 2 into a square minus x square dx. I am going to integrate with respect to x. This will become a square x minus x cube by 3 between the limits 0 to a. This 1 by 2 into, substitute the upper limit for x, a square into a will become a cube minus, instead of x substitute a cube by 3 minus the lower limit is 0, minus of 0, that gets vanished. Therefore 1 by 2 into, when you take LCM 3, this will become 3a cube minus a cube, which is equal to 2a cube, cancelling these two. The second part answer is also a cube by 3. Therefore, net answer, that is equation 1 implies, equation 1 is integral 0 to a x square root of a square minus x square plus a square minus x square by 2 dx. The answer for the first integration is a cube by 3. Similarly, for the second also a cube by 3. So the net answer is 2a cube divided by 3. Now we are going to solve the integral 1 to 2, integral 0 to x, dx dy divided by x square plus y square. So let us see the limits. That is, y values are expressed in terms of x and x as constants. So what is the order of integration? First you have to integrate with respect to y. Second you are going to integrate with respect to x. Therefore change this dx dy as dy dx. So integral 1 to 2, integral 0 to x, dy x square plus y square into dx. Now I am going to integrate first with respect to y. When you integrate with respect to y, x term is nothing but a constant. It is of the form integral dy divided by y square plus some constant square. That is of the form integral dx by x square plus a square gives you the formula 1 by a tan inverse of x by a plus c. So this, by using that formula, we can write 1 by a. Here the constant term is x, therefore 1 by x. Tan inverse of x by a, that is the formula. Here the variable is y and the constant is x. So tan inverse of y by x between the limits 0 to x dx. Integral 1 to 2, 1 by x into tan inverse of, I am going to substitute the upper limit for y. So this will become tan inverse of x by x, which gives you tan inverse of 1 minus lower limit is tan inverse of 0 by x, that is tan inverse of 0. So what is tan inverse of 1? Tan inverse of 1 value is nothing but pi by 4. So integral 1 to 2, 1 by x, this is pi by 4 minus, what is tan inverse of 0? We know that tan 0 equal to 0. Therefore tan inverse of 0 equal to 0. So pi by 4 minus of 0 into dx. Now this pi by 4 is nothing but a constant. So take it outside. So integral, the limit is 1 to 2 and the variable here is 1 by x dx. Pi by 4 into 1 by x, and integration gives you log x between the limits 1 to 2. Substitute the upper and lower limits. When you substitute the upper limit, that will become log 2 minus log 1. So this is the answer. So for this problem, the main idea is the integration by using this formula, integral dx by x square plus a square. Here we are going to integrate with respect to y, means take the x variable as constant. Therefore this will become as a in the formula. That's all. Let us pass on to the next topic, double integration in polar coordinates. We have already seen polar coordinates is nothing but representation in terms of r and theta. The integral theta 1 to theta 2, integral r1 to r2, f of r comma theta dr d theta is a double integral in polar coordinates. In this, the function f of r comma theta is first integrated with respect to r between the limits r1 and r2, and the resulting expression is integrated with respect to theta between the limits theta 1 and theta 2. Here r1 and r2, the limits of r are expressed in terms of theta, and theta limits are in terms of constants. By using this idea, let us solve this integral. Let us evaluate this integral. This is nothing but evaluation of the double integral in terms of r and theta, that is in polar coordinates. This 0 to cos theta is nothing but the r limit. Therefore, we can represent r equal to 0, r equal to cos theta. And 0 to pi by 2, this is nothing but the corresponding theta limit. Theta equal to 0, theta equal to pi by 2, r square dr d theta. Since the theta limits are constants, we are integrating theta lastly. So first we are going to integrate with respect to r only. So let us start our integration. R square on integration gives you r cube divided by 3 between the limits 0 to cos theta. Keep this integral theta equal to 0 to pi by 2 d theta as it is. R cube. Now you substitute the upper and lower limits. When you substitute the upper limit, this will become cos cube theta divided by 3. So you can take that as constant 1 by 3. Theta equal to 0 to pi by 2 d theta. The lower limit is, instead of r, we are going to substitute 0. Therefore 0 by 3 is nothing but 0. Therefore this is 0 to pi by 2 cos cube theta d theta. Now we have to evaluate this. We can evaluate by using the reduction formula. What is the reduction formula for integral 0 to pi by 2 cos power nx dx? Similarly, integral 0 to pi by 2 sin power nx dx. Please tell me the formulas for even, n equal to even and n equal to odd. That is, the formula is n minus 1 by n into n minus 3 by n minus 2 etc. 1 by 2 into pi by 2 if n is even. This is the formula for both cos power nx dx and also sin power nx dx. When it is odd means the formula n minus 1 by n, n minus 3 by n minus 2 etc. The last term is 2 by 3. Now let us apply this formula. Here the n value is cos cube theta, n equal to 3, that is an odd number. Therefore I am going to apply this formula. So the answer for that integration is 1 by 3 into n minus 1 by, that is 3 minus 1, which is equal to 2, divided by n, that is 3. We cannot find n minus 3 by n minus 2 because 3 minus 3 will become 0. Since the last term is 2 by 3, you stop with this. Therefore the answer is 1 by 3 into 2 by 3, which is equal to 2 by 9. So this is a required answer for this integral. Here we have applied the reduction formula. The reduction formula we can apply for n equal to even and n equal to odd. Since my n value is cos cube theta n equal to 3, I have chosen the formula n minus 1 by n, n minus 3 by n minus 2 etc. The last term is 2 by 3. When we substitute n equal to 3 here, the first term itself the last term in this expression. Therefore the answer for the problem is 2 by 9. Let us solve one more problem in this concept, that is in polar coordinates. Let us evaluate this integral. Integral 0 to pi by 2, integral 0 to 4 sin theta r dr d theta. First I am going to integrate with respect to r between the limits 0 to 4 sin theta. Integral 0 to pi by 2. When you integrate this r, this will become r square by 2 between the limits 0 to 4 sin theta d theta. Now substitute the limits. We can take this 2 as constant. Therefore 1 by 2 into integral 0 to pi by 2. Instead of r you substitute 4 sin theta. Therefore that will become 4 sin theta the whole square, which is nothing but 16 sin square theta d theta. When you substitute the lower limit, that will become 0 by 2 is nothing but 0. We can take this 16 as constant. 16 by 2 is nothing but 8. Integral 0 to pi by 2 sin square theta d theta. We can apply our reduction formula. What is the reduction formula for this integral 0 to pi by 2 sin power nx dx? The formula is n minus 1 by n, n minus 3 by n minus 2 etc. The last term is 1 by 2 into pi by 2. This is the formula. Here n value equal to even, that is n equal to 2. Substitute n equal to 2 here. The first term itself n minus 1, that is 2 minus 1, 1 by 2, that gives you 8 into 1 by 2. Since the first term itself the last term in the formula, it ends with 1 by 2 into pi by 2, so you can cancel this. Therefore the answer is 2 pi. Instead of using the reduction formula, you can also apply one more trigonometric formula. Sin square theta can be written as 1 minus cos 2 theta whole divided by 2. Then we can do the integration. Let us apply that procedure also. So from equation number 1, I am going to apply this step. 1 by 2 integral 0 to pi by 2, 16 into the sin square theta can be written as 1 minus cos 2 theta whole divided by 2 into d theta. That is 16 divided by this 2 into 2, integral 0 to pi by 2. I am going to integrate 1 minus cos 2 theta d theta. So this on cancellation gives you 8 times, again 4 times. Therefore 4 into integral 0 to pi by 2, 1 minus cos 2 theta d theta. Now let us start our integration. 1 is nothing but d theta. D theta on integration gives you theta minus cos 2 theta on integration gives you sin 2 theta divided by 2 between the limits 0 to pi by 2. Substitute the upper and lower limits. When you substitute the upper limit, this will become pi by 2 minus 1 by 2 into sin 2 into pi by 2. That will become sin pi. This is the upper limit, minus the lower limit is, instead of theta we are going to substitute 0. Sin 0 is also 0. Therefore there is no, the lower limit value will become 0. 4 into, this is pi by 2. What is the value of sin pi? We know the formula sin pi is equal to 0. The trigonometric value sin pi value equal to 0. This term will become 0. So 4 into pi by 2, which gives you 2 pi. So that also our answer 2 pi. So either we can apply the reduction formula sin power nx dx by choosing n equal to even, or instead of sin square we can write 1 minus cos 2 theta divided by 2, that is the trigonometric formula. Then you can apply the usual integration procedure and arrive the same answer 2 pi.